Okay, let's input our numerator. Our numerator is equal to 1, 6, and 9. So this is s plus 6s plus 9. Now we have our roots associated with the denominator. As you recall, it's minus 4, 1, and 2. We can form a polynomial in our denominator based on these roots. And we have s cubed plus s squared minus 10s plus 8. Now we use our residue function. R will give us the coefficients a, b, c. K will give us back our roots. And then we use the function residue and we put our numerator and our denominator. What we have is the following. We get back our roots, negative 4, 2, and 1. Associated with the roots negative 4 is a coefficient of 0.0333, and I'll show you that's the fraction of 1 divided by 30. And then associated with the roots 2, we have 4.1667, and that's simply 25 divided by 6. And then negative 3.2 is associated with 16 divided by 5. And I'll put a minus just to be consistent, but you get the idea of how to calculate these coefficients. And we should get the same results shown here, here, and here. And that's what we have. So that's how you do the partial fraction expansion when you're given the coefficients of the numerator as well as the coefficients of the denominator. Now, one way to find the inverse Laplace transform is use the Laplace transform function, but we need to do this, convert the variables s, y, m, s, the command, so we can convert this symbolically for s and t. And we use the Laplace domain, but let's recall what our numerator is and our denominator, and that's what we're going to use for this when we use the inverse Laplace. So Laplace. Now we're going to do the numerator, which is basically s raised to the second power plus 6 times s plus 9. We're going to divide that by s cubed plus s raised to the second power minus 10 times s plus 8. Close parentheses and close it for the function Laplace, and we should get our inverse Laplace transform that we did earlier. And we see we have our coefficients 25 divided by 6 associated with the root 2, 1/30 associated with the root minus 4, and minus 16 divided by 5 times exp t, which is associated with the root 1. So that's how you do, very simply, finding the inverse Laplace transform of a polynomial function s.